Hello, it is the start of the third chapter or third module, which called rehabilitation of the structure. So today we'll discuss the topic which connected with the reconstruction and rehabilitation of buildings. So first question that we have to discuss is the ways of strengthen building structures depending on the technological capabilities. So there are a few main ways. And the first way it's to rehabilitate it after dismantling structures or their individual elements to be reinforced. So it is the situation when we take the structural element that we need to rehabilitate and bring it to the laboratory and there modify, strengthen it, rehabilitate and return it back at the construction site. Next way is rehabilitation without dismantling the structure after unloading them from the all temporary and permanent loads. It is a very good way when we unload the structural element, we take off all the loads and after we move it and after we rehabilitate it and then return the loads back. And the third way it's without dismantling of the structures and without dismantling and in a stressed state. The most common way to rehabilitate the structural element. Also we have some methods of rehabilitation of structures. What are those methods? So first is changing of the operating conditions of the structure. Second, change of the structural scheme of the structure as a whole or its individual parts. Regulation of internal forces and structures, and the rehabilitation of individual structural elements and nodal connections. So let's start from the first method, which is called changing of the operation condition of the structures. So here we will talk about main ways. What do we have to do with the operation condition? So maybe our structural elements was exposed to water and other impacts. So it's external walls without exterior finishing. When the finishing is already cracked and was dismantled, and in that way the bricks can be exposed to the impact of the water and frozen and to weather impacts. So the way when we protect it from the weather loads, weather impacts, is the way to change the operation conditions. Also, when we reload the structural element, also we in that way we are changing the operation condition of the structures. Also, we can install special transmission devices or change the working condition of the structures. So those are the main ways to change the operation condition of structures. Also, we can change the structural scheme, design scheme of the building. So the simplest way for us, as we spend a lot of time talking about bending beam elements, is to transform the single multi-span simple supported beam into continuous beam. In that way we can redistribute the internal moments in the way as we talked previously, and in this way we have changed the structural design. Also when we set additional bearing elements, ribs, diaphragms. So also in those ways we can change the structural design scheme. And here are the main ways to change the design scheme when our building is situated above some sinkholes. We were talking previously about sinkholes, and this foundation was was supported on the ground, and now it works at the simple supported beam. And in that way we have to rehabilitate, to reinforce the lowest part of the building, so it this foundation will work as a beam. And here is the way to create such a beam under the foundation. Here the way it will look like, and in this way we can change the structural design scheme. Also we have the ability to regulate the internal forces in structures. And previous topic was also connected with the regulation of internal forces in structures, but here is the result of those works. So in this way we can even pre-stress or modify elements, and in those way to regulate the internal forces in it. So first of all, it's adding redistribution elements which change the redistribution of internal forces in these structures. And also we can discuss the method of rehabilitation of structural elements and their nodes, and we will talk about metal, reinforced concrete, and masonry structures. So first way, as we talked previously, it's rehabilitation of structural elements and their modes in the way of changing design scheme. So as we talked previously, here we can see the adding the extra support which redistributes the bending moment in the span and gives us extra support moment, but decrease these bending moments. So it can be in the way when we add 3 supports. Also, this is the way to rehabilitate the and reconstruct the beam, as we talked previously, in the way of changing design scheme, to reconstruct this node, and this reconstruction of the node leads to redistribution of bending moments, and because this beam transforms from simple support to continuous beam with support bending moments. Also, we can add various struts, hangers, brackets, in those way. So in this way we can see that adding of such an elements we can decrease the bending moment because we decrease in the length of the span. This decision is the same and this is the same, but instead of struts we using pendants, and in this way we also reduce or decrease the length of the beam, which leads to the to decrease of the bending moment in this way, and etc. Also, we can use various truss systems, which also gives us the ability to distribute bending moments, and it leads to better behavior structural element under the imposed loads to it. And in this way we can see adding of the prestressed elements, rod element. So we weld it right here. We heat it. Under the impact of heating, it enlarged, became longer. Then we weld it right here, and when the temperature comes down, these elements become, the length of this element becomes less, and it gives a prestration to this beam. Also, we can rehabilitate structures by increasing its section, by adding additional elements from the bottom and to the top. In this way we also can add additional elements only at the lower part of the element, or we can even add extra beam. Here are the main nodes of this solution, but this is those all solutions are connected with the increasing of this section of the bending elements. Also, we can rehabilitate the racks or vertical bending vertical elements by adding extra element, which gives us the ability to decrease the length of the element. Also, we can add prestressed element, which gives us the ability to minimize the compression in this structural element by using these elements, prestressed elements. Also, we can previously we were talking about metal constructions or steel constructions, and now we are talking about reinforced constructions. And main ways of rehabilitate the reinforced construction is to unload the element or reinforce with concrete, reinforced concrete, and also steel brackets. And we will talk about these according to the information that we can see at this slide. Here we can see the increasing of the section by adding extra elements, and we can see what we have done here. So previously we have removed the protective layer of the concrete. Then we add such an element, it's part of the steel rod. Then we welded element, extra extra reinforcement rod to this element. Then heat it, and as we were talking previously, after the heating, the length of this lowest element enlarges. Then we have performed this here and here, and when the temperature becomes lower, the bending element, this bending element become prestressed, and it gives us the ability to reduce the deformation of such a beam in vertical direction deformation. Also, we can, in some cases, we can increase the cross section of the element by adding extra elements at the top of the building, and this also gives us the ability to enlarge its stiffness and bearing capacity. We can use jacketing. Jacket is the overall concrete, reinforced concrete rehabilitation across the whole section from the four sides of the building, of the building elements, structural elements. The enlargement of this section gives us the bigger bearing capacity of the element. Also, we can reduce the span of the element. So here is the way it can be done with reinforced concrete element. It is almost the same that for the steel construction. Also, we can use extra elements which help us to redistribute the bending moment from the lowest part of the beam to the top, and gives us some support bending moment, and makes the span bending moment less. And here we can see the unloading bracket which help us to do this. Here is the solution to rehabilitate the column made of reinforced concrete, and as you can see, we are using jacketing. If we use in this case the vibrating of the concrete, so and in this way the thickness of the jacket will be 70-80 millimeters. So, but when we use regular shotcrete, in that case the thickness of this jacket will be not less than 50 millimeters. Also, we can use metal jacketing, or in other cases we can call it brackets, and this also increase the bearing capacity of the column to the exposed to vertical and bending vertical loads, and also connected with the bending moments. In some cases we can use three-side jacketing, and here is the solution to rehabilitate the foundation. So, and here we can see the increase of the section of the foundation by using these unloading transverse steel beam, and this is the contour of the new foundation, and here you can see the enlargement of the foundation. We can use we can increase the foundation using also increasement of this section by creating reinforced concrete jacketing, and also we can use the unloading piles. Here we can create such beam into the hole of the foundation, and these beams, cross beam connection gives us the ability to redistribute bending, to redistribute vertical impacts from these foundation on the piles. Here we can see the rehabilitation of the line foundations of the street foundation by using the unloading beam with board piles. And here we can see the rehabilitation of masonry. So there are three main ways to rehabilitate the masonry construction. So by using metal jacketing, or as we told previously, it also can be called brackets, using reinforced concrete jackets, and mortar jackets also can be used for reinforced concrete elements. The greatest effect of from three of these is given by reinforced concrete jacket is the better way, but we don't use such a solution in all the cases, because this solution gives us the significant enlargement of the section, and it impacts on our interior. So when the column becomes bigger, it can destroy the planning solution of an architect. So that is why in some cases can be used steel bracket or steel jacketing, or even mortar jacketing. And here are some ways to some practical examples of the solution as we was discussing previously. So here is the metal jacketing or metal brackets to rehabilitate these mortar columns. The solution, it's on Grandoначальницкая street, so it's not far from our academy. In this case, we have a deal with the foundation which lies on the subsiding soils, and this part of the building has settled down under the impact of water, and this part of building has the lower position on foundation, and that is why when the water comes, these wall settle down to more than those ones, and this lead to such cracks. And our solution to that case was to use extra piles which give us an ability to stabilize those deformation, but there were no found finances to this rehabilitation, and this building is still stands for our for today in those state as we can see at this photo. So also we have provided solution to rehabilitate the walls of that building by creating they called spiral anchors in the wall, and this is the also good solution for such cracks in mortar in masonry, but those are very expensive, but it's including the situation that this is the very important building to our city. It's architectural monument, so that is the way. That is why we can't increase the cross sections of the bearing elements. So here is one more monument of architecture in Odessa, and here we can see the cracks in the facades, and here are the way of metal bracketing or metal jacketing, as we told previously, to rehabilitate this building. And here are the examples of from my practice what I have found in the building in Odessa. So we can see here the sewerage pipe which is destroyed from the top part, and here all these waters comes on the floor and gives the ability to the ground to subside. Here we can see the impact of water, and here is the beam was. Here is we can see how beam was destroyed by impact of water. Yeah, and this situation is also shows us what can be on underground floors of our buildings. Here is the temporary solution to rehabilitate the building. So if you will go to the Grandoначальницкая one, you will also see those elements which helps with this building to withstand the wind. Here are some extra some extra information about cracks in the building, and these also can be reinforced by rehabilitated by using reinforced concrete jacketing or steel jacketing or spiral anchors. Here is very interesting element. This column is also is the part of the architectural monument, and that is why we can reinforce it, rehabilitate it. So we had to develop another solution of redistributing the internal forces from this above light floor, because this is the very important element from the previous centuries. And here is our Odessa's prison, and we can see the state of the walls right there. It's the masonry, and it is in a very bad condition. And also in this case we can use the solutions that we talked previously to enlarge the section of these walls by creating jacketing. So that's all for today. That's all for our course. I've made this video to help you to understand the main idea about rehabilitation. That's not good that we can meet as it was previously, but this is the only way how I can help you to have some information about rehabilitation and prepare to the future exam. So goodbye and good luck at the examination.